Hello everyone, welcome back to channel, and this is the day 2 of our Kubernetes series, and today we are going to discuss about the Kubernetes architecture. Okay, so this is the one concept which you should be aware of, and it's very important to know. Like if you're a beginner, then you should obviously know this concept. Okay, so we'll start from the scratch, and we are having some analogies also that we will see what we have. Okay, so the very two key parts which we have in a Kubernetes architecture, that is the control plane and then you have the worker nodes. Okay, so control plane just like your brain which makes all the decision, and the worker node is just like your like body parts which works for you, right? So these are the two major components of your Kubernetes, and if you have to understand with one analogy, so you can take analogy of the airport, right? So in airport you are having this control tower, which what it does, which basically manages all the operations, right? And then you have the airplanes that basically we can consider it as a worker nodes, which basically carries you from one place to another. So it basically decides, here you can see control plan, which runway to use, which plane to take off, and emergencies, everything it handles, right? In worker nodes, like it simply follows the whatever it gets instruction from the control tower. Okay, so this is the one analogy you can just think of to understand this Kubernetes architecture. So now let's just start with the like Kubernetes architecture. One component, that is the control plane. Okay, so control plane is the very main component of your Kubernetes architecture, and it is having some sub components. Okay, so it is having one API server, then one etcd you have, scheduler you have, and controller manager you have. Okay, and also one more is there, that is the cloud controller manager, which comes when you will work with the cloud environment, like cloud cluster, like you have EKS and all EKS, then in Kubernetes AKS I think, and in Google you have GKE. So EKS for AWS, AKS for your Azure, and GKE for your Google environment. Okay, Google Cloud. Okay, so these are the some of the components you have. So each is having their different roles, so that one by one we are going to cover it, what are the things. So the very first component you have, that is the API server. So this you can consider as the front door, like whatever request comes to the cluster, it comes first to this API server itself. Okay, and from there only it routes to the different components. So this is one of the flow of when you will see about the kubectl apply have deployment.yaml. So in further videos when we will do this actually, so this is the actual flow which happens. Kubectl is nothing but one CLI tool. Okay, so it this request reaches to the API server, and from API server it verifies whether you are eligible to do this certain operation or not. So basically authentication and authorization is getting checked here, and then cluster state is stored into the etcd, and after that it goes to the other components. Okay, that we'll see later on. You can see each point here you have whatever request in Kubernetes must go through the API server. That is right, it handles the authentication, authorization, whatever I told just now, and even it validates request and writes states to the etcd. So whatever changes is going to happen using the above command, that state it's going to write into this etcd. So it's just kind of the storage which maintains. Okay, then next we have another component, that is the etcd, right? So it's like the cluster's memory. So if everything is stored in etcd, like what is what is the running pods, then deployment services, config maps, secrets, namespaces. Okay, so these all things are basically the objects in Kubernetes. Okay, so that we'll see later on what are these things. Okay, but just now you can just think of it as a etcd is just the cluster's memory, which stores all the information about your cluster. Okay, and also here you can see it is the single source of truth, because it only like Kubernetes, what we can say, it trusts only etcd in case if it wants any information. So if Kubernetes wants to know the current state of the cluster, so it reads from where etcd itself. Okay, if etcd goes down, then Kubernetes loses its memory. So that is the one thing. The next component you have the scheduler. Scheduler is nothing but the it whenever you will create a new pod, then in that case it basically checks like where that pod should run, on which node it should run, what are the different certain conditions it has to check, and then it has to assign that pod to a different node. So you need to understand about the pod and node as well. So For now, you can just think pod as one container, and node is just like one server you can think of. So where that container will run. So this is one basic thing which I can tell you at this moment, because you're not aware of this pod and node right now. So here you can see till now, like scheduler is the smart planner new pod created. So basically which worker node should run it, and what are the checks it does, like how much CPU is free, available memory, node condition, Taints toleration, affinity rules. So these are some of the concepts which we will cover further. And in result, like it will assign that pod to a particular node which matches. So for example, if your pod needs some less memory, so and the node is available, so it will assign that pod to that particular node. So this is the scheduler. Then you have the main part, that is the controller manager. That is basically with the help of this only Kubernetes is able to do the self healing. Okay, self healing means if any pod is there, if it crashes, then automatically it will come up because of controller manager itself. So here it basically constantly checks whether everything is running as expected or not. So basically here you can just think of this flow. So you declare like three replicas, like three pods should run for your application. So three pods are running happily. So now what happens, node 2 pod goes down. So once some pod will be there and it goes down of node 2. So in that case, what happens? CM detects, that is the cluster controller manager detects like only 2 by 3 pods are running. So what it does, it again schedule new pod immediately to make sure your 3 pods should be always running. So this is one job of controller manager, and this is basically called as the reconciliation. Okay, so this is the one word you should be always remember for controller manager. Then you have the worker nodes. So till now we have covered this master node, that is the control plane. Now worker nodes, you have actually three main components here you get basically, that is the kubelet, and then you have the container runtime and the kube-proxy. So kubelet is basically this is one agent which runs on all the nodes, and it is responsible for like pulling images and all everything. Okay, so it basically communicates with the control plane and ensure pods are created and running. And even you can see in container runtime, like it basically used to run those containers. So what is the thing actually? So basically you are having a pod, and in pod what runs in pod, basically your container only is running. So c1, you can in one pod you can run multiple containers like c1, c2, c3, like that. And kube-proxy is basically used for the networking thing, like how you traffic will reach to your pod and how it should inbound and outbound, all those things, and it maintains some tables and all. Okay, so this is about your worker nodes. And here you have a different thing like okay, so now let's just discuss about the worker node components we have. So same thing we just told you, right? Kubelet, you have container runtime, kube-proxy. So kubelet basically runs on every node, receive pod spec from API servers. So this is your API server, this is your node, here kubelet is running, and they both basically communicate with each other. And container runtime job is to pull container images from the registry, and also it creates and manages container lifecycle. Okay, then you have kube-proxy, that is also runs on every node as a daemon set. Basically we'll discuss about what daemon set is later on. Then that is used for implementing community service networking. So basically it is used for the networking. Okay, so let's understand the full flow when you deploy certain like deployment YAML and all. So this is the full flow. Basically API server is there, receives and validates the request, and after that it stores the desired state to the cluster. Scheduler used to select the best worker node, controller manager ensure desired pod count should met, and then kubelet is basically it receives instruction that it has to schedule a pod on that node. Then after that, container runtime will basically pull that image and start the container. And kube-proxy basically used for the service networking, and then your app will be live. Okay, so basically this question this full flow you should be aware of. Okay, so this is the full flow basically, and let's now just recap the everything. Like you have the control plane. Control plane will have the API server, which is the entry point for all the requests. Then you have the etcd to store the cluster state. Scheduler used to choose the best worker node for your pods. Control manager maintains the desired state, And worker node, you have the kubelet, which will execute pod instructions whatever will be there, and in container runtime will run the containers. Kube-proxy will handle the pod networking. So this is the basic thing. And at the last we can say like control plane decides what should happen, and worker node basically executes it, so which actually do the work. Okay, so this is all about the Kubernetes architecture. I know you might feel overwhelmed because this is your first time you're reading, and even you can go through the official documentation to understand more deeply. Okay, so I'll just attach the link of the official documentation as well. So in the next video we are going to basically do the hands-on. We'll be installing the local cluster, and yeah, so that's it for this video guys, and I will see you next one. Thank you so much for watching.